So I think we are live now, and I want to say hello to all the people who are watching this. Uh, I'm Metta Spencer, and we've been struggling with our equipment here, but I think we're about ready to say hello to folks out there in the wide, wide world, and welcome you to another one of our weekly talk shows. So, this is going to be a different one for me because I'm in over my head. I've got two fellows who are going to talk about something that I know zero about, but they are no doubt perfectly able to carry on a conversation without any help from me. One of them, I'm going to ask John Straub to say hello so that you'll see that I'm now speaking. That was John Straub. If in fact Zoom did what it was supposed to do, show his picture. And John Straub is a professor of building science at the University of Waterloo and very knowledgeable about energy efficient building technology, codes, and standards. And next on my screen to him is Steve Kemp. Say hello, Steve Kemp, because it brings your photo up. It hasn't done it yet, though.
No? How many times do I need to say hello?
There you go. All right. Yeah, there's Steve Kemp. Steve is an engineer who's an expert in energy codes and net zero energy buildings. Mm-hmm. How about that? And those two guys work together a lot because they're both involved with something called RDH Building. It's a company. So apparently not all of their energy goes into academic life. They're actually out there building buildings. And if we hadn't had so much time struggling with our technology here and it was behaving badly, I might know a little bit about the subject by now because I would have probed them. But what we are going to be talking about, and by the way, later I expect that we will be joined by another man who's also an expert in the same area named Greg Allen, who is an engineer who specialized in low energy buildings. And it says here, he's also a vocal opponent of nuclear energy. And I think he will probably, when he comes on, he will probably spend some time talking about things like fracking, which, and how much that has to do with building codes, but there you go. Anyway, as some of you realize, just a month ago now, we had the forum that I'd been working on all year, practically. And that forum produced something called the Platform for Survival, which is a list of 25 different public policy proposals that some of them were fairly visionary, some of them were quite realistic, that if adopted should have some significant influence in reducing the probability of 6 global threats. And those are, of course, you may know, war and weapons, especially nuclear, global warming, famine, pandemics, major radiation exposure, and cyber attacks. And if you're interested in how those are interdependent, I suggest that you go to our website, which is called tosavetheworld.ca. And we've been doing some work on that. There's a special thing on there that I like very much, a new page called Intersections or something like that, looking at the relationships among, the causal relationships among all of these different threats. And there's a little box with numbers in it, and you run your mouse across one of the numbers, and a thing pops up giving you the explanation of how those two things are related, you know, like cyber and famine or something like that. So, and there's one for every, it's a matrix. So it's every combination of those 6 things. They're all interrelated. Have a look at that if you haven't done so already, and you may want to make comments about it. Anyway, one of the items on there, which surprised me because I'd never heard of this before, was this proposal. The International Code Council shall adopt stringent performance-based building codes. And this was in the section on global warming. So I asked what that's all about. Who is the International Code Council? And I was told that buildings actually emit a very large, like 35 or 40% of the CO2 in the atmosphere. And that therefore we really need to pay attention to how we build our houses and offices and so on. So that's why these two guys are here with us. And I don't know whether you want to begin by telling me what this International Code Council is. Steve, would you explain what that is and why it is or isn't very important?
And John, correct me if I'm wrong, I believe this is actually a U.S. body, even though they call themselves the International Code Council.
Yep.
It's sort of like they call baseball the World Series, and yet it's played more with the U.S. But they are a body that's responsible for setting base minimum energy codes for both single-family homes, small buildings, as well as large commercial buildings. And it's up to various governments to adopt those codes or other codes. There's other codes out there like ASHRAE. In Canada, we have something called the NECB, the National Energy Code for Buildings, but it's up to the provinces or local jurisdictions to adopt those codes.
I think it's also worth pointing out that building codes evolved over time to protect consumers, primarily for things like fire and structural failure. And then they started to take on a role of public safety in terms of, believe it or not, plumbing. Because in the 1920s, lots of people were dying of typhoid epidemics because untreated wastewater was being put into open waterways and water was being contaminated. So they worried on the plumbing side to make sure people didn't get sick. So we stopped killing people because of fire and structural collapse, and that's still embodied in all building codes in Europe, Japan, etc., not just here. And then they moved into more public safety issues like plumbing and water safety. And this is one of the reasons why energy was added after the big shocks of the oil crisis in the 70s, to say it is a public good to minimize the waste of energy. And so slowly we started adding requirements in building codes to the set of things that we had to do. It wasn't enough to make a strong enough beam. We also had to make a building that didn't waste energy. And so the part of the building codes that we're talking about today are the parts that relate to energy, because that pretty directly relates to carbon dioxide, and that relates directly to climate change.
Correct.
While you were talking, which I only half got to listen to because we have just been joined by Greg Allen. So hello, Greg.
Greg's on mute.
Can I hear you? Please.
No, he's on mute.
Are you muted?
Bottom left corner.
Greg? Down in the left corner of your screen, there's probably a little microphone or something with a line through it.
You should hear me.
You got it. Very good. All right. Hello, Greg.
Hello, everybody.
Good to see you.
Hello, Greg.
Hey, Greg.
Very good. Well, I'm glad you're here. And I guess you all know each other, right?
Yes.
Absolutely. Many years.
It's a small community.
Okay, so I'm afraid that I was only half listening to you, John, because I was preoccupied. But this, you were explaining how these building codes arise. As I understand from Sandra, although this International Code Council is a U.S. outfit, apparently a number of countries, rather than developing their own codes, they simply buy into or take over the standards of that code council. So I guess that is the basis for the argument that it might have more impact than just in the US. Is that correct?
That's true. Although, frankly, the other reason I would suggest it has a big impact is that the US has a lot of buildings that are pretty crappy. And so improving that can make in terms of tons of CO2 emitted, probably more important. Although ASHRAE, as Steve mentioned, is another code body that is also used around the world, including Europe and the Middle East and parts of Asia. So there are a couple of code bodies one could work with to try and get as much bang for buck, if you will, in terms of minimizing carbon emissions.
Mm-hmm. Okay. So now you imply that the U.S. Has crappy buildings. Well, that's news to me. And are you saying that our buildings are better than the U.S. buildings in general? That our code Canada's code is better than the American code?
Well, I'll let Greg and Steve deal with that after I pulled the pin on the grenade.
John probably has more experience with American buildings than I do. But certainly when I look at what Canada's been doing in the last 2 or 3 years, City of Toronto is certainly trying to take a very big leadership position with their energy code. They're basically have adopted a City of Toronto green standard, which has a very stringent energy code going forward that actually also directly says that you have to limit the amount of greenhouse gas emissions associated with your building with the energy that the building consumes. City of Vancouver is going that way, so is BC, and now we're waiting for the rest of the provinces to hopefully get into the competition of who's going to be the greenest jurisdiction for new construction.
So you're saying that Canada isn't a single unified code?
No.
It's all local.
Yeah. There is a document published by the Natural Research Council of Canada called the National Energy Code for Buildings, but it's local provinces that adopt it, or that sometimes they adopt the ASHRAE code of the U.S. And in Ontario, we adopted both. You can choose.
Greg, you came into firefight, but it hasn't emerged as a very strong one yet. Do you have a position on the incendiary question I asked, whether U.S. buildings are worse than Canadian buildings overall?
Well, first of all, we shouldn't crow in Canada yet. There are certainly other jurisdictions in the world that have been ahead of us on codes, the European Union and whatnot. Mm-hmm. I'd just like to say, though, that the building codes follow advancements that are made by the industry in the first case. So they kind of bring up the basement on buildings. It takes a lot of years to see significant changes, and I've been dealing with trying to improve the building codes for now 45 years. So it's a slow process that way. So it's important to understand the not only the mechanisms of how codes evolve, but also what is going to drive them to where we need to get to, which is to make sure that at least anything that's within the jurisdiction of the code doesn't result in building buildings that are irrelevant 20 years down the line because they're still using hydrocarbons.
So what actually are the things that need to be done to improve I guess, with respect to carbon emissions? What needs to be done to tighten up the codes and make buildings more efficient? Can you sort of rank order what are the important things and what are trivial?
Like I always tell my clients, there's no silver bullet to doing this. It's you have to pull on all the levers. So it's everything from more insulation in the walls, better design details for pallet installations put on the walls, certainly better windows. I would love to see our code mandate triple glazed windows tomorrow. And then after that, it's lighting, fan power, how we push air around the building pumps, but then the heating systems themselves. We're still, at least in Canada, we're still a cold climate, so we need much more efficient heating systems.
You know, I read a thing called Drawdown. I don't know whether you're familiar with this book edited by Paul Hawken. I think it's the most interesting book I've read in the last 5 years. I try to get everybody in the world to read it because what he did is he got about, maybe 1,000 experts together. I mean, not that they got together, but he asked them to each do some research in figuring out what are the most effective ways of reducing global warming and carbon emissions. And they rank ordered them. They did their calculations on efficiency and effectiveness, and they rank ordered them. And they put in a whole bunch of things having to do with carbon emissions. So I wonder if they didn't talk about building codes as such. They talked about specific things. And one of the things they mentioned was the desirability of something called district heating. What is district heating? Now, when I've been to Russia a lot, and Moscow has one heating system so that all the heat in the whole city comes from certain local plants, I guess, that hold a whole district of the city will be heated by the same facility. I didn't think that was a very effective or efficient idea, but is that what they mean by district heating? And would you guys concur that that's a useful innovation?
Well, you're correct that that's what's meant by district heating. Places like Moscow is a great example. Although maybe it's a good, bad example. And they do it better in places like Sweden and Denmark. But it's hardly a panacea. And technology has been moving forward enough that it's actually becoming less of a solution than it once was. There still is a role for it. I mean, particularly in things like using biofuel plants that generate electricity, and then the waste heat could service buildings is for space heating and domestic hot water. But there's a lot of cost involved in running insulated pipes between buildings. A lot of loss of heat, as you see. I've been to Russia, and you can see where all the pipes are because that's where there's no snow on the ground, because all the leaking heat melts the snow away. And but places like Sweden that have already installed a lot of piping and so on. It's hard for me to see that as a top 200 solution or something like that.
No, it was about the 30th. Mm-hmm.
Greg, you're usually the visionary here. Like, do you see a way that we can use district heat to make a meaningful impact relative to some of the other technologies?
Because of the cost of running pipe between buildings, it only makes sense to do it in dense areas like downtown cities, and a lot of the downtowns of Canadian cities. Toronto, Montreal, Vancouver all have district energy plants because the economics are there to make that work. But you're right, most district energy plants are no more efficient than the heating system you could put in the building itself. The biggest advantage they have is because of the scale of them, you could invest into some interesting things like cogeneration, large scale heat pumps, which I think is what Edmonton is looking at with their new development, what I think is near the old airport, or what was the old airport. They're putting in a low temperature system that I think is going to be based on heat pumps. But really, it's just that scale that gives you the opportunity to look at technologies that you couldn't normally look at on a building-by-building basis as cost effectively.
Greg, were you, just rubbing your head, or were you waving? You want attention?
Yes. I actually am an advocate for exploiting as much as possible where it is the density support district energy, because it holds a lot of answers to some unanswered problems. For a start, if we're going to go off of natural gas, it represents quite a bit more energy than the electricity grid currently generates. And it all happens at times when we all need it and it's least available. So renewables like solar don't serve too well displacing heating. So that's a problem to solve. It involves not just building performance and energy efficiency in buildings, but also a fuel substitution to an electricity-based system, and in some cases a biomass-based system. My analysis suggests that we're going to need to put more biomass onto the electricity grid because it's able to be dispatched when we need it. And it's also coincident with space heating. So if you use biomass to generate electricity and you use that heat locally, because you can only use heat locally, then you've solved a big chunk of the problem. We've got a lot of buildings out there that aren't going to be feasibly upgraded to passive house standards. And so we have a problem set that to be solved in the next 10 to 20 years that involves a massive transition from natural gas to other forms. Another application of district energy from the heating standpoint is the use of geothermal storage. This is not unfamiliar to Europeans, but it's only been tried once in Canada in any scale, where you store summer heat in the ground and extract it in the winter for doing space heating. There's a lot of improvements to be made with that technology, but it applies to a district scale and not an individual building scale.
Correct.
We do have an excellent example in Toronto of a district energy system in the form of the deep lake water cooling system.
Of what?
Deep lake water cooling.
Oh, yeah.
So we took all of the downtown off of electricity to supply that load, which made an enormous reduction in GHG emissions, as well as eased up on the peak demands for electricity in the downtown area.
Maybe you could elaborate, if you will, on this notion of transitioning away from natural gas, because you mentioned that Trudeau, Pierre Trudeau, had made a demand for change a while back, and that it was done very quickly. Can you? This was all news to me, so would you repeat it for our audience?
Well, there's various things that I would suggest our current government in Ottawa is culpable of in terms of their lack of demonstration of following through on their commitments to make the 1.5C rise. In terms of natural gas, it's perceived still as a part of the solution set, whereas with any reasonable accounting of the upstream emissions associated with natural gas, the methane emissions, and recognizing that methane is the most critical short-term emission that we need to reduce if we hope to meet the 1.5C target, we're going to have to get off of natural gas. We got off of oil in the 70s through a federal program. Unfortunately, we transitioned from one fossil fuel to another at that time. This time we need to go largely off into electricity, but the electricity system has to be a co-partner in evolving a solution set. It's not enough to say we're building energy efficient buildings that are using heat pumps and leave it to the utilities to figure out how to manage that, because at the building level, it's a lot that can be done more economically to match demand and supply.
So how much of a challenge is that? Can it be easily done?
Technically, I can illustrate in a vast assemblage of options. Right now, most of us are looking at the energy performance side without looking at the supply side importance. That question is not being suitably addressed at this point. It's not without solutions, it's just not being examined properly.
Well, and also the supply side is so different. So in Ontario, Canada, we have a very low carbon source of electricity. In Alberta, the electricity has a really high carbon content. And so, you know, it's a very true statement that we can't look at just fixing the code to say make buildings more efficient without considering where the energy they do use is coming from. And primarily in the climate change question, it is, and what's the carbon emissions? And in Alberta, as an example, or PEI, I think is even worse. I think they burn old rubber tires to make electricity in PEI, judging by their carbon emissions. They use a lot. In Ontario and Quebec, BC, Manitoba, I think those are the ones, right, Steve? You know, they have very clean grids. And so switching to electricity today makes a pretty big impact. And so somehow we have to get our grids all to be as clean across the country, like Greg's saying. And it depends. Technically, is that the problem? Of course not. It's just a money problem. I mean, it's $1 trillion, and one can replace a lot of the generating infrastructure that's already been built with something that's low carbon. But it's a lot of stranded assets, a lot of vested interests who said, I've planned for 40 years out of this coal plant, and you're going to make me shut it down after 20, or my natural gas plant now. It's like, I planned for 30 years on this natural plant. You can't make me stop it after 20 years. So there is a money issue going on there. But eventually, we got to solve it sometime and in some way. So,
yeah, the Canadian Green Building Council published a report earlier this year that, and I can't attest to the veracity of the claim, but the claim is that I think it's in around 2030, 2032, even the Alberta grid is projected to be clean enough that you could consider using heat pumps to heat buildings and be ahead on greenhouse gases. Whether that's hopes and dreams that will or won't happen, I don't know. We've certainly seen plans go awry before.
I need an explanation here. Now, wait a minute. What is it you're saying? That if Alberta continues to use oil, that heat pumps will be able to handle the problems that are caused by that? That's not what you're saying. What are you saying?
Well, some of the emissions from our buildings are what we call upstream or indirect emissions. And actually, all the emissions with respect to electricity are upstream or indirect emissions, because the tailpipe is not in your building. The tailpipe is where that electricity is being generated. And so in Alberta, the tailpipe is largely coal plants. And so right now, if you were to heat your house with a heat pump in Alberta, you are making more greenhouse gas emissions upstream at that coal plant than you would if you just heated your house with natural gas. If we use our traditional accounting for the greenhouse gas emissions of natural gas. And what this report is suggesting is that in 15 years, the cleaning of the Alberta grid will be such that you might be better off using heat pumps as they take more coal off that grid and replace it. I don't know what else they're replacing it with. That's the veracity of the report. I don't understand.
Well, that in fact is the issue, because if we're going to sizably increase the wintertime demand for electricity across the board, even in Quebec, you will have a shortfall of capacity that will be met if nothing else is done by fossil fuels. At the very least, heat pumps should be designed to operate only in off-peak hours, and that is not a difficult thing to do. We used to conventionally have hot water heaters, hot water heaters that were turned on and off by the utility so that they weren't coming on in the daytime when they had peak loads. So these aren't technical problems that are hard to solve. They are problems that are not being solved because there's no signaling and no co-planning of future electricity grid to meet new heat pump loads.
Mm-hmm.
This is unfortunately a little bit, it's kind of interesting how we go from building codes and climate change and start talking about energy supply. But I think that's actually correct, is that you can't decouple these problems.
Right.
And as we, what we're hoping for out of building codes is that we're hoping that buildings will be made more energy efficient, will demand less energy per square foot or per square meter of space. But that doesn't solve the problem on its own. That's only one part of the problem. And the other part is, well, where's the energy supply coming from and how is it going to be cleaned up? How is it going to be matching the need for energy at the time the building wants it and the ability to deliver the energy when it's available? And so that's why there is a need, and this is well understood, I think, at the policy level, to integrate the utilities, the distribution, the consumption, and the storage of energy in a way that was never done before. That is a major challenge. That is, and again, technically, not a huge deal. Economically, not even that great of a deal. It's a major system change, and people resist change in general. And so, yes, it's probably going to cost some money, but I don't think that's actually the big obstacle. It's more that it's a change of the whole paradigm. Utilities are not just producing power and selling it. And people who build buildings don't just follow a set of rules and then build the building. You actually have to somehow synchronize those two. And that takes a lot more communication. And it's not as easy to do as just each of us doing our own thing in our own silos.
Mm-hmm. Let me go back to what you said a little while ago about the clean energy. And I think you were celebrating Ontario as a better source of clean energy. Obviously, you had in mind the fact that we get so much of our energy from nuclear. The people who adopted this platform for survival also favored in general a transition away from nuclear power to other forms of sustainable energy. Now the question is, how long is that going to take, and how practical how much is that going to affect the building industry and the cost of energy and so on? Nobody came up with a date. You know, how long is this going to take for us to shut down nuclear power plants like Pickering? Nobody has even proposed a timetable for that. But that's certainly the intention that I think the majority of the people there had in mind. Can you comment on that? I know it's taking you even farther away from your own expertise in building codes, but still, you brought it up, so.
Well, I would hope it's going to bring our energy costs down. Nuclear is an extremely, it was not the way it was meant to be, but, or at least when nuclear came onto the grid in Ontario, it was supposed to be too cheap to measure. But it's an incredibly expensive source of energy. And the main reason those plants are still running is they're, as John said, they're entrenched assets. We've paid for them already. But I can't imagine we'll ever pay for another one. It's just too expensive.
Well, we even tried it, actually. We actually tried an honest open source bidding and found that the prices, and that's not even the full price because they're not including what to do with the waste, the prices were stupid. They were through the roof, right? They literally rejected all options from a world bidding to provide 2 large power plants. And they just said, well, that's just too much money. So it's a good question because those are one of the many stranded assets in the power generation business that we have to do something with. Nuclear is, of course, the most complicated because it leaves behind the biggest legacy. But we've already spent billions making Pickering. And so people aren't going to shut it down willy-nilly, but they sure as hell aren't going to build another one. And it's a matter of when that one wears out, how soon is the earliest plausible date to shut that down and start dealing with the waste? I mean, that's something that others may know more about when that plausible date is. Maybe Great.
I've been in the trenches against nuclear for all of my life, so I've followed this deeply and intently. Of course, in Ontario, Pickering is at end of life, and they're going to try to beat the dead horse for another 3 years. They've cut off new renewable generation in the province just about, and they're planning on building a whole fleet of new gas plants to replace the power when they take the other reactors off grid. Over the next 20 years, there'll be 2 to 3 reactors off at any one time for refurbishment. So we're putting good money after bad already, and we've already committed to contracts to put in a whole bunch of new natural gas, which will bring Ontario back to where it was in the coal days.
In the cold days?
Yeah, the good old coal-fired days that we thought we put an end to. We're now replacing it with natural gas plants that, when fully accounted, are at least as bad, some say much worse than coal plants themselves. So
we don't get to hear much about that, and I wonder, because you were speaking to me about that earlier today. Can you elaborate on that? I mean, you mentioned this thing about fracking, which scared me because I didn't know about it. Could you elaborate on that a little bit, Greg, and inform our audience?
Sure. So North America peaked in conventional natural gas production just after the year 2000. In other words, we had stopped being able to find enough new wells to replace the aging wells that were simply drilling in the ground, and out comes the gas. So the savior, in quotations, was to take what's called tight gas or shale gas into production by fracking it, which is essentially breaking up the rock to let the gas out. The process is intrinsically subject to leakage of methane, and some of the gas fields have been demonstrated, shown by aerial testing, site testing, and satellite testing to be producing about 10% of its gas production is lost to the atmosphere.
10%.
So we're at about 60 or 70% of the North American supply is now from fracking. Mm-hmm. And it will become virtually all of it, all of the new supply. If we continue to demand gas, it will be supplied by drilling more holes, of which we have about 500,000 now. These fields are subject to a lot of debate. There's some that believe in the environmental community that we can pressure the industry into doing the smart thing and closing up the leaks, but they've only suggested that 45% is feasible. Over what timeline? It's anybody's guess. It's been deferred by the federal government. And
Greg, the quality of your sound is not so good. Could you get a little closer to the mic? And I'm not
I'll get close.
Keep
Is
talking,
that better?
if that helps.
Is that better?
I don't know. Keep talking and I'll see.
Okay. So the next 10 years, we'll see most of our new gas production coming from more fracking, and those fracked wells will largely be leaking enough gas to make it several times higher than competing fuels in terms of proper accounting for natural gas. The problem with methane is that it's been growing rapidly in the atmosphere. It only lasts a few years in the atmosphere because it oxidizes quickly. But when it's in the atmosphere, is extremely powerful and accounts for about half of the what they call radiative driving force for climate warming. The good news is if we can get that methane generation level down quickly, it will disappear from the atmosphere and we'll get some breathing room to get the carbon dioxide down. So it's of utmost urgency that we focus on in North America, which by some research out of MIT that we're getting about, we're culpable for about 50% of the increase in methane over the last decade in North America for our gas production. My bigger concern is that these fields are exhibiting leakage by other paths than the wells themselves, because the rock is fractured to layers that are over them that were not tight, that were fractured. It's escaping into water aquifers, and it's making its way to the surface. We haven't tested that, but those leaks may continue for decades or centuries afterwards. Mm-hmm. And there's no way we can seal them. So every new hole is another contributor to sustained methane release. So I'm pretty emphatic that we need to focus on shifting away from natural gas as quickly as possible as the most potent thing that we can do to avert climate change disaster.
That's very important. I mean, I assume it scares me anyway. Thank you. Could we go back to building codes and some wild thoughts that occur to me? Things like, well, I live in a high rise, and the next building over, last year they put something up on the exterior of the walls. I think they were gluing up some sort of insulation on the outside of the wall or something. Is this the way of the future? And other things like green roofs or painting the roofs white. What are these just silly thoughts, or how realistic are some of the rather draconian measures that I hear discussed in the press and that I don't see actually happening around my neighborhood?
Well, so let me just talk about the insulation glued to the outside of your neighbor's high rise. That's a pretty established technology, not expensive, and can be used, but doesn't always have that effect, can be used to make a significant improvement in energy consumption, reduction in energy consumption, improvement in comfort. And the reason that they're doing that is usually not for energy. It's because the building needs sprucing up. The facade is looking aged and tired. And so this is where building codes come in, is that when someone is going to spruce up their exterior of their building because it's old and tired and has been worn out by the weather, we would like them to have to do better than the very minimum of just putting a lick of paint on it. And what you saw with adding the insulation is a pretty modest cost relative to the lick of paint that would otherwise go. So that exterior recladding is something that certainly in Europe has gotten a lot of attention, because we have to address not just new buildings, which most people think about in building codes. We have a huge amount of work to do in dealing with at least half the problem in terms of carbon is dealing with the buildings we've already built. The buildings that were code approved in 1986 are pretty bad. And so we have to fix those. And so technologies like this exterior overclad absolutely make sense, worthwhile, lots of options, and we're still getting better and smarter at that. Green roofs don't actually save much energy. They may help with the solar heating in the summer. They certainly make a more attractive looking roof, and they help with stormwater management. But if you really cared about reducing heat gain through your roof, you'd put more insulation on the roof. That's the bang for buck, no scientific argument to doing it. But people talk about green roofs because, well, green roofs are like, they're sexy. I mean, look at them. They are green. And so, of course, people want green roofs. They're not bad, but they're on their own. They really can't do much.
Yeah. If you notice the energy saving from your green roof, you probably don't have enough insulation there in the first place.
If you can notice, right. If you can notice that you're saving energy, it's because you don't have enough insulation. And to a certain extent, even white roofs are like that. Nothing wrong with white roofs. There's a whole bunch of good reasons to have a white roof. Keep the city cooler, keep your roof cooler, that makes your roof last longer. Does it save energy? Yes. Although, again, we should be putting enough insulation on the roof where the difference is modest. But still, definitely worth doing given how inexpensive it is to do so. And there, and Steve mentioned earlier things like changing windows, or we need better windows. Windows are almost always the worst performing parts of our building skins. And so often that means that any chance you get to change your windows at end of life, when the gaskets fail and they start to rot if they're wood windows or get brittle if they're vinyl windows, changing them to really good performing windows is almost always worth it. And, simple, consumer ideas is, triple glazing, that kind of stuff, pretty much a no-brainer. And this is what would be put into retrofit codes to say, when you're replacing windows, you should put in better windows than what you have, at least, that kind of stuff. That's where the codes would come in. And they're not currently as focused on the existing retrofit market, although there has been move at the policy level to understand that, to say, we need to do better, says policymakers. I know Ontario has done work. The Department of Energy in the United States has done work to say retrofit is a big part of the problem of the future. So we have to make our codes more explicit and more firm about how we manage these existing buildings.
I'll add one more thing, John. I think that we have to recognize our thermal bridging detailing architecturally has contributed at least as much as the glazing and wall systems, particularly in multi-residential buildings. I shouldn't choose jargon. So there have been some inclusions in ASHRAE and code references, but I see a little response by the industry that seems that the building inspectors are ignoring it. Just for those who might not be familiar with thermal bridges, the most spectacular one is when you see a building festooned with concrete balconies that are cantilevered out into the air. And if you were able to see in the infrared, you would see that they were aglow in the winter, giving off heat, and in the summer, conducting heat right back in.
So many people, Metta, would think about things like insulation. In fact, the natural response of the public and even less sophisticated policymakers is they think this is a materials problem, and it isn't. It is a systems design problem, and it doesn't matter how much insulation I put in if the balcony penetrates through, like Greg says, or if I put in a crappy patio door, like Steve says. So, like Steve said, with multiple levers, it's like, well, we kind of got to do a good job on all those areas, and it's not about a green roof as much as it is about having an insulated roof with no thermal bridges and no air leaks. It's not as much about putting lots of insulation on the walls. It's more about making sure that we have a continuous layer of insulation with no air leakage, connected properly to windows. And just saying that means I've run out of characters on Twitter. And so that's part of the challenge that we face, is that this is a little bit, it's actually not technologically complex, but it's a little bit more complicated than buy more insulation, buy a good window. It just takes a little bit more than that level of sophistication to get the full value out without wasting resources.
When you mentioned the glass, I've heard people talking, complaining about these beautiful glass high-rise office buildings that are clad in glass, and the argument is that is a very bad design from the standpoint of global warming. Can you comment on that? Is that true? That these glass buildings?
Go, Steve.
Yeah, I would say most certainly. John likes to complain that we talk about the performance of windows in U value, and because if we talked about the performance of windows in R value, you'd know how bad they are. And so those all glass buildings are insulated to roughly R3. Would you buy our house and only ask for R3 insulation in the walls? That'd be even today we recognize that's a really foolish thing to do, and yet that's what we're building.
What is this R3? This is apparently ranking of connectivity.
Yeah, it's a measure of how much insulation we think the wall has, and R3 isn't very much.
R is for resistance. That's what the R stands for. It's not like a pirate call, the R value. It's actually resistance to thermal flow. And we would hope that even with all the thermal bridging and stuff, we would hope that a built to code Ontario home has an R value in the order of, say, 13 to 15. And so when you see a spanking new office building where they spent literally 5 times as much per square foot getting R3, as an engineer, you look at it and you're saying, what a waste. They spent a lot of money and they didn't get a lot other than shiny. And that seems to be the primary driver. It's got to be shiny and smooth and imported from China. Those are key attributes of what we want in modern condos and high rises.
The other thing is that windows can be, they are a big part of a solution side too. They can be avoid having to have all the lights on a commercial building if you do it smart, and they can be gainers of heat in the winter months. There's technology out there that's well available, but it's going to cost something more at the upfront, which is always a problem. Developers just want to have the cheapest building that they can get off their hands. So there is glass now manufactured in North America that has a vacuum between the two panes of glass, and it's R11. You can add another layer and get the thermal bridging down of the edge effects, which would then give you about R16, and you can put a surface on it that can change dark when you don't want the heat. So you can reject the heat from coming into the building. Those incremental costs, on a number of occasions I've demonstrated, are actually reducing the capital cost of the building because the heating and cooling plants are subsequently reduced in cost more than it costs for upgrading the window performance.
Wow.
And this is why it's not a simple buy this and get that, right? So Greg's describing sort of what we would all be doing. That's what our job as engineers is, right? To say, well, look, if we put it here, we can save it there, but don't forget about that, right? And so lighting, heating, cooling, view, all have to be thought together as opposed to in different silos by different professionals. And you need to take the long-term view. And that's sort of the magic of when we get to work on great buildings, is when we're able to integrate all the parts and look beyond a 6 or 7 year cash flow pro forma that a developer looks at. And that's how we can explain that Greg's been working on stupidly low energy buildings for at least 30 years before I knew what they were. And we have built functional examples, successful examples of zero energy buildings that are 20 years old, gazoodles of them that are 10 years old. So it explains why we can both achieve really low energy buildings, because it's not a fact of technology or materials as much as it is getting the right group of people together with the right goals that they're trying to achieve something. That's how all these great buildings come into existence. And yet the public, and again, far too many policymakers think that if only we could invent a widget, if only we could invent a cheaper insulation. And it's like, that's never the problem. Shouldn't say never, but rarely the problem. It's the problem of getting the people to integrate all those functions together and to think beyond the 3 to 7 year cycle of normal buildings, even though everyone acknowledges that buildings that last 7 years would be a joke. Everybody knows the buildings are going to be there for 25 to 75, but we all plan for 7 on an economics basis. Not surprisingly, they end up being not economic.
Why do you do that? You plan for 7 years for a building to last 7 years?
Not to last, but that's where you expect to make your money back as a developer. So that's the timeline around which investments are based. So if I have to spend more money on the building and it will take 8 to 10 years to pay back, commercial developers will say no.
Mm-hmm. Okay, so are you complaining then that the problem is in the buyer, that the buyer is not well enough informed to know his own interests, long-term interests, and that people are demanding things like glass buildings with R of 3 because that's cheaper and they look pretty now, and that's
let me start in, because I think the others, Greg and Steve, should say something about this too. But first of all, the developer building the building for 7 years is not doing something irrational. That person, she's looking after her own best interests. The problem is that buildings are beyond individual investors' interests. This is a part of the public infrastructure, and we can't just pretend it is about your decision as a developer to make money. That's step number one. Step number two, the developer who builds a building doesn't necessarily care much about the energy consumption, because the way the commercial world works today, they don't pay the energy bills. It is the tenant who rents the building who pays the energy bills. And so there's a complete disconnect between the decision makers and the people who pay the price. When you buy a condominium building, you end up paying the energy costs, not the developer. And so the challenge about the glass buildings is it is sold as if it is a snazzy design, but that's what it's done. It's sold as. And yet it's actually not cheaper than alternatives that are better. It is just a snazzy design. And from a person trying to move those condos, not a surprise, they choose a thing that the public is snazziest and attractive. And so if you're talking condos, absolutely, education is important, and we need to do a much better job. But in a lot of the commercial sectors, it's more a matter, what we call the agency problem, where the person making the decisions and the investments are not the people who pay the price. The people who pay the price are the long-term tenants and society at large. And so that
I think you've just made a big case for regulation. It sounds as if this is a perfect place for NGOs who are working on global warming to put some energy into saying, tighten up these building codes so that we don't have, that we restrict the power of the consumer in determining
the wrong thing.
The builder.
Well, I don't think you're going to hear a lot of disagreement from this group of people, but we're all kind of eccentric wackos.
Well, yeah, but you see, I know I'm an average person with at least an average, not much above average, but at least an average awareness of the problem that we do have to solve global warming. And all of this is new to me. And if somebody had told me yesterday or a month ago that we should spend more time trying to tighten up building codes so that we overcome these problems, I wouldn't have been very interested, frankly. I wonder how many people will be even watching this show, because I don't think many people have.
Well, it sounds like a boring topic. If only they'd known how exciting the three speakers were.
That's right.
Well, it's partly an habituation of what people assume to be the case. We talk about 3-year paybacks and 5-year paybacks and all of this simplistic talk. I've once said that I thought engineers should have their thumbs removed because they use rule of thumbs too often. The issue really came to light for me, and I was doing specification documents for a big hospital. It's the Humber River Regional Hospital, which is a public-private partnership project. Now, you would think that because the public purse was on the hook for not just the capital, but also the maintenance and operating costs of the building, that they would want to optimize for that. And they did so with the operating side because they had the competition bid in 30 years of maintenance and operation of the building, except for energy. And I said, why did you do that when you've got the greatest opportunity in the world to improve the performance of your hospitals? You're driving all in the right direction. They said, well, because the cost of energy is unknowable. It could get so high that they would bid the prices too high. And I said, so do you think that the public purse, the bureaucrats, are any better than developers on figuring out how to negotiate the best price in anticipation of high costs? What they do is to minimize the risk by making energy such a small operating cost that it no longer affects their bid.
Mm-hmm.
They don't have to take that risk. And so these are just faulty thinking that we've got going on everywhere. And codes alone won't do it. Codes are good. I think we all agree that good codes can improve the situation. We need also to be able to motivate the design community to be rewarded for building better life cycle cost buildings. They aren't right now. You pay a penalty if you design a building with more thought process going into it.
You bet.
And if you do anything innovative, you're liable to be litigated whether it had anything to do with the innovation or not.
Yes.
So there's no financial incentive for the design communities to do a better job. These are perverse norms.
Perverse incentives. It's actually always surprising to me how many firms want to do it because they know it's the right thing to do and they campaign for it and routinely lose. But the incentives totally push them in the other direction. You're completely right. The incentives are don't take a risk, don't do something innovative, don't think longer terms, and yet luckily there's still people doing it because there's enough good people in the design world that recognize that it's the right thing to do, and so we get some good buildings.
You know, we just are getting to the nitty gritty as our hour is over. I'm actually fascinated by the question of what you would all agree should be the next steps in trying to change public awareness or actually the law, the building codes, in the direction that we need to move.
I don't think we need to choose, Metta. I think the answer to those questions is yes. We need to improve regulation, we need to raise standards, and we need to increase awareness. And it's not just in the building code side, it's also in things as diverse as we were describing energy generation and carbon accounting in the energy network. We haven't even had a chance to talk about how the interconnection between transportation and buildings. So buildings that are built downtown, buildings that are built close to rail transport, et cetera, clearly have a better environmental footprint than those that aren't. And so we need to include all of those things, not one lever, to use Steve's terms earlier in the show. It's not one lever. We need to push on all fronts. Well, it's a big enough problem and we have to move fast enough. We pretty much have to do everything.
Mm-hmm. Well, I wonder if we should come back and give another try to this conversation and see where it goes, say 6 months from now, or a few months from now, because I the reason for my doing these weekly talk shows is just to try to influence public awareness, and that includes my own awareness. So I'm extremely grateful to you all for making me a little bit more aware and making me more troubled than I was about what we should do next. So I'm really grateful for this. I'm going to boost this on Facebook so that we'll get as many viewers as possible. And I want to invite our viewers who are with us up to this end to come in again next week, because every week, every Monday night, from 8 to 9 p.m. Eastern Time, we'll be having another conversation about matters that we need to handle in order to save the world from various global threats. And this obviously is one of them. So thank you, fellas. And I'm going to say goodnight now.
Yeah.
Bye.
Good night, all.
Bye.
Bye.